what sort of decision are we going to be making in the long run? Now, in the long run, we've said that all our inputs are variable. So if all our inputs are variable, we're going to be having both capital and labor changing as we want to change our output. Now, the different combinations of inputs that will yield the producer the same level of output would be given by what we call an isoquant. So if you are producing, what would happen is that you are going to be able to combine, let's say, 15 units of capital and 15 units of labor. That probably would give you 100 units of, let's say, or 100 boxes of water. You can change your combination of capital and labor to also give you the same 100 units of water or 100 boxes of water. So in this case, you can have 15 units of capital and let's say 50 units of labor. That still can give you 100 boxes of water. And so you can have different combinations of capital and labor that would give you the same level of output. That curve, if traced, is going to give you what we call an isoquant. Okay, so this is really how the isoquant looks like. The isoquant slopes downwards because, like I'm saying, we can have different combinations of capital and labor that would give you the same level of output. So here, for instance, we're having A showing, let's say, 20 units of capital and 15 units of labor, giving you 100 units or 100 boxes of water. B would give you, let's say, 10 units of capital and then 50 units of labor. That would still give you 100 units. And you can have several of such points. If you trace that point, those points, it gives you what we call an isoquant. Now, how does an isoquant look like? You can see here that I've drawn an isoquant that slopes downwards. This is a typical isoquant. Obviously, you can have some abnormal isoquants, but this is a typical isoquant. Now, it slopes downwards because you prefer to use both capital and labor. And because you prefer to use both capital and labor, to use more of labor, you need to sacrifice capital. Remember the concept of scarcity that we spoke about earlier on in this course. So to have more of labor, you need to reduce how much of capital you are using. And that continues and makes the isoquants downward sloping. Now, isoquants that are found above other isoquants obviously would yield a higher level of output compared to those below. And that should make sense to you. If you take an isoquant that is above, at least it's going to be giving you more of one unit or more of one input than the other. And remember, the more inputs you use, the more output you get. And so isoquants that are found above the others are isoquants that would yield higher levels of output. Another thing that you'd have to know is that the slope of the isoquant is obviously negative because it slopes downwards. And the slope of the isoquant gives you minus change in capital over change in labor. Now, this minus change in capital over change in labor is what we call the marginal rate of technical substitution. And under this circumstance, L for K, because K is on the y-axis and L is on the x-axis. K is what you are sacrificing to get more of L. Now, this change in capital, minus change in capital over change in labor, it can also be expressed as the marginal product of labor over the marginal product of capital. Why is this so? Now, we've said earlier on that points that are found on the same isoquant would give the same level of output. So irrespective of whether you're on point A or on point B, you're still going to be having 100 units and 100 units. Okay? So let's say that we want to move from point A to point B. Now, to move from point A to point B, we would first have to reduce our capital and then increase our labor. And then we'll still move from point A to point B and get the same level of output. So to understand this better, let's decompose this whole thing into its two constituents. So we are at point A. First of all, let's say that we are reducing our capital. We are not increasing our labor yet. Obviously, if we reduce our capital units, our output is going to be reducing as well. So how much is our output going to be reducing by? It's going to be reducing exactly by how many units of capital we tend to reduce our capital by, times the marginal product of capital. So you see it over there. Let's go to the second point where we try to increase our labor units. This time we are not even thinking about what happens to capital. If we increase our labor units, obviously our output is also going to be increasing. How much is our output going to be increasing by? It's going to be increasing by the change in our labor units times the marginal product of labor. Now we can combine both. Combining both would mean that we are moving now from point A to point B. So we are reducing our capital and increasing our labor to arrive at point B. Now remember, when we get to point B, we really don't want our output to change. And so the reduction in output that came about because we have reduced capital should exactly offset the increase in output that has come because we have increased our labor units. So I've put here minus change in Y should be equal to change in Y. And therefore, change in K times MPK should be equal to change in L times MPL. And if we rearrange, we have minus change in K over change in L being equal to MPL over MPK. So we've seen here that the slope of the isoquant is also equal to the ratio of the marginal products, in this case, marginal product of labor over the marginal product of capital. Now, remember what our objective is. Our objective as a firm is to maximize profit. So if our objective as a firm is to maximize profit, our intention here will be looking at selecting the right amount of inputs that we need to use. We are in the long run. We can vary all inputs. Doesn't mean that because we can vary all inputs, if we want to increase our output because we want to make profit, we can change all the inputs that we have and still have our output increasing indefinitely? Not necessarily. Remember, we are faced with constraints in the world. We cannot have everything that we want. And in this particular case, our major constraint is going to be the cost bit. So if our major constraint is going to be the cost bit, in maximizing our profits, we need to factor in our cost. In our production process, we need to factor in our cost. What will be our cost? Our cost obviously is going to be the production cost. There are two inputs here, labor and capital, which means that if you are factoring in our cost would be equal to the cost of labor, which you see over here, WL, plus the cost of capital, which you see here, RK. Given that with the isoquant, we had K on the y-axis and L on the x-axis, if we are factoring in our cost, we need to be very consistent. And so with our cost over here, our K should be on the x-axis, on the y-axis, sorry. So we make K the subject. If we make K the subject, we end up with K equals C over R minus W over R times L. Our slope here becomes minus W over R. So in selecting the right combination of inputs, we need to make sure that we find a point where we'll be maximizing profit. The point where we'll be maximizing our profits will be when minus W over R would just be equal to the ratio of the marginal products which we found, i.e. the slope of the isocost would just be equal to the slope of the isoquant under the circumstance. So minus W over R being equal to minus MPL over MPK. This obviously is going to be giving us the right combination of inputs that we need to be able to select, or if the firm has to produce efficiently. Now, MPL, if we are giving a production function, we can obviously find. MPK, we can also find. And then we'll obviously have the cost of labor and the cost of capital. Now, so we are looking at a typical example over here, which says that suppose that a firm produces an output level where the marginal product of labor is 50 units and the wage rate is $25. Suppose further that the marginal product of capital MPK is 100 units and the rental product of capital PK is $40. Is this firm producing efficiently? If a firm is not producing efficiently, how might it do so? You can look at how I've solved it to check whether your answer is right. It's not every time that you be giving the marginal product in figures. You can also be given it in the production function terms, and you'd have to work your way through. Take a look at your different books and take examples. Thank you so much for your attention. Hope you enjoyed this session.